Hi kiddos, welcome back. This is our final water station lab, station 6. So before we get started, let's go ahead and review what those 4 properties of water are. Property number 1, it sticks to itself, also known as cohesion. Property number 2, it sticks to other substances, also known as adhesion. Property number 3, it dissolves many substances. And property number 4, it absorbs large amounts of heat. Now, we've already previously shown in our labs 1 through 5, it sticks to itself, it sticks to other substances, and it absorbs many substances. So, this lab is going to show you how water can absorb large amounts of heat. Materials you're going to need for this lab: 2 balloons, 2 little candle tea lights, some water, a lighter or match, safety goggles, a funnel, and that'll be it. If you decide to do this lab at home, I think it's great. However, please make sure you have the proper safety equipment and you're wearing it, and also have supervision from a parent because it deals with an open flame. All right, the other thing I want to talk to you about real quick, just a little content connection here, is what water looks like in its different states. Now, we all know the 3 different states are solid, liquid, and gas, okay? Now, gas is when all of the particles are really, really spread out, which means it's not very compact, which means it's going to be the least dense state water has. Moving on to solid, all of the particles are getting a little closer together, so they're going to be more dense than gas. But then if you look at liquid, liquid has the most particles and they're really close together. So liquid is the most dense state, this is the middle density, and this is the least dense. Now, water expands when it freezes. So when it goes from liquid form to solid form, it's going to spread out. And notice the particles on my drawing spread out as well. More open space between molecules and ice than liquid water, which means that ice is going to be less dense than liquid water, which is why your ice is able to float in your waters, because the state of ice, the solid state, is less dense than the state of liquid. Okay? All right, so now that we got that content check, I'm going to get my balloons stretched out a little bit so that I'm ready to blow them up. I'm going to go ahead and light my candles too, get them warming up. And then I'm going to go ahead and put my safety goggles on. All right, the blue balloon is just going to be air, so I'm going to go ahead and I am going to blow that up first, since it's just air. Perfect. Okay. Now the water one I'm going to blow up a little bit so that it's expanded, and then I'm going to put some water in it. And I'm going to let that out, and then I'm going to fill it up with some water. Now, I don't have a whole lot of water in here, so I'm going to let out some of the air. I might add a little bit more water. Sometimes you got to try this a couple of times before you have enough water in it. Okay. All right, and I'm gonna tie this one off. All right, notice that one of the flames on my candle is looking real weak and the other one's looking really, really good. So what I'm gonna do is I'm actually gonna blow out this weak one, and I'm just gonna use the one candle so that we make sure our data is nice and accurate, and like the flame intensity is not a factor that affects it. So we're just gonna do one at a time. We're gonna do the one with just air first. And notice they are pretty close to the same size. No major difference there. The only major difference we're seeing, this one has only air, and this one has a good amount of water. Okay, so watch and see what happens. I'm gonna hold it about an inch or so above. Woo! And it popped right off the bat. All right, let's see what happens to the one that's got water. Oh, and it did blow out my candle, so I will go ahead and relight that. Okay, now this one has water. I'm gonna try to hold it the same amount. Make sure all the water. There we go. Now notice it's not popping like the other one did. And the reason being is because the water that's on the bottom of this balloon is absorbing that heat. And so instead of it making the balloon pop, the water is taking in that heat, which is saying that the balloon will not pop then until that water cannot hold any more heat. And you can kind of see the bottom of the balloons getting a little darker because it's being roasted by the candle. And even as I sit here, it still isn't popping because it has that water to absorb that heat. We'll give it a few more minutes. Very cool, huh? So the water in the balloon made a very big difference because the water in the balloon made the balloon not pop. When it was just water, the balloon popped almost instantly. All right. Thanks for watching, guys. And don't forget to do your Google Forms after this, and I'll see you next time for our next video. Bye, guys.